She's really worked to improve the aviation weather safety throughout the weather education and partnerships with that local aviation community. And when we decided we wanted to have this conference in Reno, it was amazing to see the aviation weather contacts, especially with general aviation, in those relationships she's already really developed. She apparently does have spare time, though I haven't figured out when. So outside of work, she does the outdoor stuff. She does cooking and baking. And then she and her husband are pretty busy taking on new adventures. They have a 6-year-old and 4-year-old boy-girl twins. And she's had all 3 birthdays in the past couple weeks. So at some point, I think she's going to get a break. All righty, Dawn, thank you very much. I think you're all set. It's all yours.
All right, thanks so much for the introduction, Sarah. And yes, it has been a very busy month. Got to say, when I was going into the spring, I knew I had this workshop. I had another big group event I was working on. I had a family member having a wedding. We had all 3 kids' birthdays, and I was like, how are we going to get it all done? And then we added a pandemic. That was definitely an unexpected situation. Of course, none of us would have expected what happened to have happened. But let's go ahead and move on and talk about low-level wind shear at Reno. Now, this is something that I studied a few years back because we tended to have a lot of issues with wind shear, and it was a big concern from the control tower out of Reno. But we weren't always sure exactly what was causing it, and our theories were not always correct. I really wanted to kind of dive back into this and explore this because, we were originally going to be having this talk in Reno, and with a lot of local pilots in the area, I thought it'd be good information to pass along. So just for fun, the picture you're looking at is actually a view from our office. Yes, we do get to look at that gorgeous view all the time. Granted, we did have a nice, colorful sunrise at that point, but where we were originally going to have it was at the Desert Research Institute, just down the road from our office, and you would have had almost the same view out of the meeting room. So sorry to rub that one in. Hopefully one of these years we will get this back in Reno and we get to have it in person. So why did I want to look at wind shear? Well, I guess I mentioned, huge impact to aviation at Reno, and it's not just at Reno, it's really for any of the airports around our area. I have been told from pretty much every airport that we do terminal forecasting for that they have seen windsocks at each end of the runway and at center field blowing in different directions at the same time. Now, I can only imagine being a pilot trying to fly in during something like that. High respect for those pilots flying into this mountainous terrain. It is not easy. From a forecaster perspective, low-level wind shear was fairly misunderstood. We just thought, okay, high winds, probably bringing us some shear. Our goal, though, was to see if there happened to be any patterns that would generate low-level wind shear more frequently at Reno and ultimately learn how to forecast it better. So December 15th of 2016, we happened to have a pretty good wind event going on, and we had gotten a lot of wind shear reports that day. Here are some actual PIREPs. This particular one is talking about rotor action and how the aircraft almost rolled at 8,500 feet off the ground. Oh my gosh, I would not have wanted to be there. The next one, we're talking about, on final here, we're at flight level just 1,000 feet off the surface, wind shear 30 to 40 knots, updrafts and downdrafts of 1,500 to 2,000 feet. Now, can you imagine being pulled around like that when you were that close to the surface? And finally here, we're looking at another wind shear report showing really strong shear and many diverts and go-arounds. So on this particular day, I did happen to be working, and we do like to listen to the ATC chat, the air traffic controller chat rooms. And I actually heard a pilot. I watched it from our office. We're about 5 miles north and about 5 miles to the north and about 500 feet higher than the airport. And we watch a lot of these aircrafts coming into the airport. And we saw this plane coming in, looked pretty sketchy, and they did a missed approach, flew out of there. Pilot said to the control tower, "I want nothing to do with this place. Get me the hell out of here." It was that bad. So some samples from some of our bad wind shear days here. A lot of flights canceled or diverted. We're looking at anywhere from 15 to 25% of flights. And we're talking just commercial here. This does not include general aviation. I have a feeling on these particular days, we're not really seeing much general aviation, which is a good thing. So some common causes of low-level wind shear. Any of the meteorologists on here who have gone through the comment modules, and by the way, these comment modules are available to anyone. So if you look up as a pilot, the comment program and wind shear, you're likely to find this, and you can go through these online as well. We can definitely share that resource. But mountain valley effects, low-level jet streams and inversions, lee side effects or gap winds, and fronts coming through. Now, where the Reno airport is, we sit in a nice valley surrounded by mountains. We see every single one of these effects. But what is separating those days that really stand out, and we have a lot of problems from the days where we just might have like 1 or 2 light wind shear reports? Let's first take a look at the airport. As I mentioned, we're basically sitting at the bottom of the valley. The base of the valley is a little over 4,400 feet in elevation. The airport itself is somewhat central. It's kind of on the southeast side of town, although realistically speaking, we've had a lot of extension in our city to the north, the south, and the west. Reno has grown rapidly in the recent years here. And if you look at some of the terrain coming in, this is coming in from the south. You know, keep in mind the main runways basically run north-south. There is an east-west runway, but it is shorter and a more difficult approach given the terrain, and we almost, shouldn't say never, but very rarely will ever see commercial aircraft using that approach. If we get a little closer there, you'll notice that little hillside, for anyone who isn't from the area, that is Rattlesnake Mountain. We tend to get a lot of bumps and rotors off of that, so not so fun when you're coming in on final and you pass by. From the west, you see the I-80 corridor, especially where the Truckee River flows through, and you get a lot of wind funneling through that canyon in basically westerly into the city. Come a little closer, same view. From the east, more terrain. I-80 continues eastbound along with the Truckee River flowing out. That is where the divot is, and that is typically where the winds are going to flow through as well. Getting a little closer there. And from the north, so our office happens to be north of the airport, as I mentioned, about 5 miles to the north and just up on the hillside there. And more terrain. The valley itself just slopes upward, you climb, and then you get into more valleys up to the north as well. So let's talk about the methodology behind this. So first off, I started looking for archive PIREPs. You'd think this would be easy to find, but believe it or not so easy. At first, I wasn't finding much of anything, and then I came across Iowa State started doing it in 2015. The problems, though, are that PIREPs do not have to fit any kind of specific format. So some of the reports are actually unparsable, data is possibly incomplete. I'm also limited to actual reports. We really love getting those pilot reports. I have to say that, you know, I hear stories where pilots are like, oh, I couldn't do it at the time, and I felt that a couple hours later was too late. But meteorologists can use this information even past the point for research purposes, and that way we can learn better about the weather patterns in the area. So pilots, please make sure you're submitting those PIREPs even if it is after the fact. My other issue was that I couldn't actually do a search for a particular airport. So I had to parse it slowly down, and I couldn't kind of like search by date ranges or anything else. So I had to just kind of slowly keep parsing and keep recasting the fishing net, so to speak. I only wanted non-convective low-level wind shear. And since we do tend to see summertime thunderstorms, I did not include the summer months in this study. So after all that, I ended up with 48 days over about a almost 2-year period there. And as I mentioned, I excluded the summer months of June, July, and August. I wanted to focus on kind of the, quote, bigger days because all those effects that we talked about earlier can cause low-level wind shear at random times, and decided to use days that had at least 3 or more low-level wind shear reports. So that took it down to 19 days. We went ahead and looked at observations at Reno for these days of the study, and I wanted to look at basically plus or minus 3 hours of the actual timing of the low-level wind shear report. And use MesoWest data to explore the lower-level OBS within the valley. If anyone hasn't used MesoWest, there's some great tools where you can go and find archived weather data, you can look at maps, and you can pull things up from any number of days. And I know that I do have that in my speaker notes that we'll be sharing so that if you are interested, you can find that as well. Ridge level winds, so winds aloft approximately 700 millibars. Anyone here in the local area, that's basically looking at around Big Mount Rose or Slide Mountain, more or less 10,000 feet. Archive surface analysis to look at fronts and such, and also soundings for Reno. I'd like to also point out, so soundings we do at our office, and so our office is 500 feet off the valley floor, and we don't always sample exactly what's going on the valley floor itself. Then I wanted to look at the various components of the wind, breaking it up into zonal and meridional components. Look at where the jet is, look at the anomalies, look at where the anomalies were at ridge level, and then also around 850 millibars. I realized I forgot to put the millibar at the end there, but that's all right. But 850 millibars basically translates to around the surface layer. Also looking at height anomalies. Are we seeing height falls? Do we have approaching systems? Are there frontal boundaries? Any number of those items. So remember how I said at the beginning, we thought, okay, high winds for sure. That is low-level wind shear for us. Turns out there really wasn't a direct correlation. Yes, it did take wind, but we didn't see higher average sustained speeds correlating with a greater number of low-level wind shear reports. And the difference between the sustained speeds and the speed gust spread also didn't have a correlation, which is another one of these things that kind of broke our thought mold on what we were dealing with. Now, looking at the peak gust stats, 58% of the cases did have winds at least 50 miles an hour or greater. Anyone who has ever been to Reno, it is a windy place. We get a lot of winds. As Sarah has alluded to, she refuses to fly in here because of our winds and all the pirates she saw while she was at Salt Lake Center. But we see winds gusting, 30 to 40 plus miles an hour all the time. We actually get gusts around 30 every single day in the summer because of something known as the Washoe Zephyr. Actually, we have a nice little YouTube video on our office page if you are interested in such things. It's a downslope wind during the day, which is very atypical. That being said, though, that actually leaves still 42% of cases below advisory criteria. And if you really look at those stronger wind events, say 60 mile an hour greater winds, less than 0.5%. And the west wind events had peak gusts less than 40. So yes, wind, but no, it didn't mean that the stronger wind cases meant wind shear. So we went ahead and broke things down into the anomalies, looking at all of the events, kind of the top 11 and then the top 3. And I believe the top 3 events, I just had a plethora, just tons and tons of reports of low-level wind shear. You can see the anomalies there a little bit stronger as you get into the top events and more extended inland as well. The zonal anomalies, though, where your low-level jet might be, and this would be more off the coast. For the 700 meridional anomalies, you can see it more moving inland, a little bit stronger of a component as well. And in this case, now this is like the ridge level jet. It is now moving basically farther inland. But you do notice in the top events, it is not quite as robust as you might expect. Looking at more of the jet level winds now, the meridional component is more to the north of the area, as is the jet component as well. So what we did find is that southerly wind events, so when we get winds out of the south at Reno, this accounted for 84% of the events. I mean, that is a huge number. So that really opened our eyes to being like, okay, if we're having south winds and they're blowing a little bit, we're probably going to be seeing some wind shear. We also saw clear cases of rotors present in more than half the events. And keep in mind, rotors, sometimes you will see a rotor cloud. Sometimes you will not see a rotor cloud. It just depends on the moisture. So don't always count on the clouds to be your sign there. In 42% of the cases, the winds went from calm or nearly calm to howling, so a sudden inversion break. And only 2 events had a clear wind shift from south to west, and only 1 featured west winds. This also happened to be a very clear wind shift with the frontal passage. And as we know, frontal passages with the wind shift, you can definitely get low-level wind shear. I'm going to share this video instead of playing it just because of bandwidth issues here. Give me just one moment. I will post it into our chat. There you go. You should be seeing that shortly. But what's really interesting about this video is it actually wasn't that long ago. I'm trying to remember the exact date, but off the top of my head, I can't remember the exact date. However, it was in the last few months. You can see, though, the strong southwesterly flow, and then all of a sudden you're starting to see a dust plume coming out from the east, and that was because of a rotor near the airport. Video was taken from the office. I don't know if in this little picture here, if you can see where my cursor is there, that's actually pointing towards the Grand Sierra Resort, and then right next to that over here, that's the airport. So take a look at that video and you'll be able to see a nice visual of a rotor taking place right over the airport. As I mentioned, it's all about direction when it comes down to these low-level wind shear events. Speed plays a role, but direction more than anything else. We talked about how the valley was oriented. You can see how the winds like to flow more westerly to southwesterly through the I-80 corridor. Definite clear-cut southwest coming out from the Carson Range there. We actually have some very wind-prone locations out over here by Galena for anyone who lives there. I know Sandy, our next presenter, actually lives in that area, and he's more than familiar with the gusty winds we can see out there. I have noticed when we get kind of a south-southeast component to the winds at the airport, in the vicinity of the airport, that actually tends to be even worse as far as wind shear, just the way that we're seeing the winds funnel through the terrain. And you can see some really strong wind event cases here. These are some southeasterly winds to our south, where they're still more westerly out to the west. And you can see these are some screaming wind speeds going around into the airport here. And then in the case here, March 21st, 2016, on our right, you can see that northeasterly wind barb. Take a look at all the other wind barbs in the area. They are all south, southwest, west. So what do you think's going on there? I know I can't really ask the audience, but clear-cut rotor. I would love to say we can forecast when we're going to get rotors, when they're going to stop, when the winds will shift back. Our tower at Reno would love me to be able to do that. But unfortunately, I do not have such powers. These are such small-scale features that can form and break on a whim. And unfortunately, we do not have high enough resolution models to be able to forecast something like that. So if you're seeing observations like that, probably best just to avoid flying. So in the soundings, things you want to look at both your model sounding and your actual sounding. Do you see light winds at the surface and then much stronger winds within 5,000 feet of the surface? When are these winds going to mix down? Take a look, at least for Reno, we like to look at southerly or southeasterly at the surface with southwesterly just off the surface. That tends to cause wind shear as well. For any meteorologists on the call still, take a look at your local airports. You might be able to find patterns there that actually cause this as well. Here's some example. These are the actual soundings, and keep in mind, they are taken at our office. Our office is just shy of 5,000 feet north Reno. We're located basically across the street from Truckee Meadows Community College and the Desert Research Institute for anyone who is in the local area. So we're not sampling what's going on right on the valley floor. But you can see here, lowest levels, light and southeasterly. Just above it, a lot of strong southwesterly flow. An example here, low-level southerly winds, and then we start getting in again, strong southwesterly flow. One more time, we got the southeast winds at the surface. You can see a nice clear-cut inversion layer here. Once that mixes out, we're going to get these stronger gusts filtering down as well. The best practices we have learned. As I mentioned, key in on those south wind events. Look at the anomalies and how they might line up compared to previous events. And this is something that's done more on the meteorology side. Focus on the flow through the valley. This is something pilots you can do. You can take a look at these observations. There's MesoWest, there's a great observation page through the Weather Service as well that you can really see the terrain and look at all the observations that are available through the valley. But focus in on how the flow is. Are there areas that are lining up to possibly bring wind shear? We also have a winds aloft page on weather.gov/Reno where you can find observations from Peavine. You can find observations on Slide Mountain. You can look at Virginia Peak. You can look over on the Squaw side and Alpine and see what is going on up there as well. Remember, if we see rotors, it's a guarantee there is wind shear present. And you're not always going to see the cloud. Be aware of frontal passages. Oftentimes we're going to see some wind shear right ahead of the front and then along the front. We tend to see less wind shear behind the front, just because we see more of the upper level and the lower level flow aligning at that.
All right, looks like we've got a quick lost connection with Dawn. She's doing this from home with a few different backup internet options. So it may take a moment for her to get back. And as she said earlier, my desire to fly into Reno is pretty much non-existent, and her talks kind of reassure that for me. But I had a road trip planned from Salt Lake to Reno just to not have to fly into the Reno airport. I think it was going to be about an 8-hour drive, and Charlotte and I were going to make that together. It was going to be a perfectly planned trip because no desire to fly into that, and just left, that's what